Welcome back, guys. Today we are back with another problem, and today's problem is finding the minimum cost of the ropes. So this is again an interesting problem. They have given it an easy problem, but yeah, it's easy if you can know how to find out the minimum cost. But like using the naive approach, we'll get a cost which is higher than the most efficient approach by using a priority queue. So what we will be solving without any delay in understanding this problem, we are going to solve this particular problem, and then we are going to analyze this particular set of problem. Okay. So let us first take one demo example. So if I have the, say for example, I have an array, okay? I have an array and the elements of my array are 2, 5, 4, 8, 6, and 9, okay? 2, 5, 4, 8, 6, and 9. Now, say for example, what I want to do is, I want to find, the question it is saying is, that we given an array, we have to find, given an array and the length of the different ropes, we need to connect these ropes to form a particular one rope. The cost to connect is equal to the sum of their lengths. Okay, so we have this thing and we have a cost. Say cost equals to this. Suppose we want to connect two ropes. Okay, suppose when you are using the basic approach, what we will be doing is we will be adding the two ropes and making it into one rope. So this becomes 7. Okay, so what we are going to do is in our cost we are going to put 7. Okay, in our cost we are going to put 7. Now again, what we have is a 7 along with 4. Okay, so what we will be having is this value becomes an 11. Okay, so in our cost, what we are going to add is what we're going to add is 11. Okay, so now we have updated the cost like this. Okay, similarly, what we are done with 4, when you are done with 4, we are going to add this 11 to this particular 8. So this value becomes now as 19. Okay, so what we are going to do is we're going to add 19. Okay, similarly, this value becomes now 19 and 6. Okay, so what we're going to do is we're going to add this entire 6 with 9. So what we're going to get 25. Okay, we will get a 25. So we are going to add 25 along with this. Okay, similarly, last but not the least, we have 9 over here. So we are going to add, what we're going to do is we're going to clearly add 25 plus 9. Okay, so this value becomes, so I have to just check whether I have done the 25 plus 9, so this value becomes 34. So what we are going to do is we're going to put 34 over here. Now when we do this total sum, what we can see, we are getting a 7 plus 18 and this. So we are getting a total sum of 96. Okay, we are getting a total cost equals to 96. But now the question comes, is this particular cost is my minimum cost? Minimum or not? Minimum or not? This is the question. So definitely no, this is not the minimum cost. In some other ways also, we can make the cost more minimum if we know the more efficient approach with the help of a priority queue. So what we are going to we can say use priority queue to minimize the cost. And say use a priority queue to minimize the cost. So when I'm saying that we have to use a priority queue to minimize the cost, what are the values we can take for this particular example? What are the values we can take for this particular example? Okay. Say for example, what we have initially, we have 2, 5, 4, 8, 6, and 9. Okay. So now I'm going to solve it with the help of the priority queue approach. Okay. I'm going to solve with the help of priority queue approach. So if I see 2, 5, 4, 8, 6, and 9, what are the two most lowest values? What you can see is the two most lowest values are 2, 4. The 2 and 4 are the two most. Now what I'll be doing is I'll be keeping my cost equals to initial cost as nothing. So I'll be taking 4 and 2's addition. So making another array which will have 5 as the initial one. Now 2 and 4 which becomes 6. Okay. And then we have 8, 6, and 9. Okay. 8, 6, and 9. And my cost as usual, initial cost was 2 and 4. So cost becomes 6. Okay. So now I have the cost as well. Okay. What is the next value which I can get? So what I have seen is 2 is gone, 4 is gone. Okay. So what is left is 5, 6, 8, 6, and 9. So among all these values, what are the lowest values? What you can see? What are the lowest values? The lowest value is 5 and 6, right? So what I will be writing is 11. Okay. After that, we have 8, 6, and 9. So we are going to add a cost plus 11. Okay. Once we are done with this, what you can see is the lowest values. What are the lowest values? Just try to think of the lowest values. So the lowest value is 8 and 9, 8 and 6. So if we add these two ropes, what we are going to get? A 14. Okay, we are going to get a 14. Now, once we get a 14, we are going to update the 14 over here. And similarly, what we can see, what is our lowest values now? So the lowest value is 11 and 14. 11 and 14, no. My lowest value is 11 and 9. So what I'll be doing is I'll be adding 11 and 9. So this becomes 20. Okay, and 14. So I'll be adding a 20 over here. Okay, once this is done, what I can see is I have 20 and 14. Now, what are the two values? I have only left with two values, right? So what I'll be doing is 20 and 14, I'll be getting a cost of 34. Okay. I'll be getting this last value as 34. So I'll be adding over here 34. Okay. So now let's add up and do the summation. Okay. So I have 4 over here, 4, 8, 9. So this becomes 9 over here. So 3, 4, 5, 6, 7. Okay. And let me just check. 4, 5, 9. Sorry, I don't have 9. And this becomes a 5. And so 3, 4, 5, 6, 7, 85. So let me just check whether I'm getting the correct value. So yeah, if I just carefully check what is the value I'm getting a 9085. Okay, so 5 and 4, which is 9, and 6, 15, 5, and 2, 3, 4, 5, 6, 7, 85. So what I can draw the conclusion is this particular way, in this particular way, the cost which I'm getting is far lesser than 85 is lesser than 96. So the minimum cost. So the question is again, welcome back to the question. The question is find the minimum cost of the rows. So what we can see is the minimum cost of the rows have been reduced. That means we are able to find the successful minimum cost of the row. Okay. So let us check 4, 3, 2, and 6. Let us check the example 4, 3, 2, and 6. We have 4, 3, 2, and 6. Okay. Let us take the two minimum values. Let us take the two minimum values. The minimum value and the cost we will be updating over here. The cost equals to this. So if you take the minimum value, what you can see is 3 and 2, this becomes 5, and then we have 6. Okay. So we will be adding cost equals to 5. Now, what is my minimum values? What we can see is we have 4 and 5. Okay. So 4 and 5 becomes 9. Okay. So I'll be adding 5 plus 9. Okay. And we have a 6 over here. 5 plus 9, so 9, and then we have 6 over here. What is the two values left? Now we are only left with these two values. So this becomes 15. Okay. And once this is 15, what I'll be doing is I'll be adding a 15. Okay. So the answer which I'm getting is a 29. Okay. The answer which I'm getting is a 29. Okay. So what you can clearly see, we have got the answer as 29 with the one given in the question as well. So now we have 29 as well, right? So what if I solve this using my basic approach? So if I have the array of the rows, I have the array of the rows as 4, 3, 2, and 6. Okay. What if I try to solve this with the basic of the approach? So basic approach is what you can see is 4 plus 3 is 7. Okay. What you can see is 4 plus 3 is 7. Now, so you will be putting a 7 over here. You'll be putting a 7 over here. Now, what is your next task? We are done with this, right? So you will be adding another row. Okay. So what you can see is 9. Okay. So you'll be adding 9 over here. 7. Let's just check. I guess we have to add it with 3 as well. Okay, we have to add it with 3. So this becomes 4 plus 3, this is 7. Okay, with 3, so this becomes a 10. And when 10 is then adding a 12, and then 12 with this 6. So definitely this value is far more greater than the value of 29, far more greater than the value of 29. So this is not a valid approach. So we will be sticking with this particular approach of the priority queue, and we are going to solve this particular problem with the help of priority queue. Okay, so how we are going to solve this and everything, we are going to follow the coding and implementation part so that you can understand this. So we'll be just going over here. Okay, so what I can clearly see is I have a minimum cost over here. I have a minimum cost. So in this, I'll be initializing a priority queue. So I can write priority queue of the type integer. Okay, ABC is my priority queue equals to new. Okay, so I made the priority queue as well. Okay, so if you can clearly see that I've made the priority queue. Now what is my task? I have to move in the queue and add the elements, right? So I'll be doing int I equals to 0. Okay, and I less than what I can say is I less than the array. So array dot length. Okay, I plus plus. Okay, so I can just take the length. Okay, that's also done. So I've taken it. So what I'll be doing is I'll be adding. So I can say abc.add. Okay, I'll be adding the priority queue. So I can write my array as arr of I. Okay, array of I. So what I can see is I'm adding the priority queue. Next, what is the thing? Next, you have to add it to the cost, right? So what I can do is I can create a cost value. So I can say cost equals to 0. Okay, so everything can be really long. So I will take long cost. Okay, in this case also we are going to take long. So if I'm also taking the priority queue also, let me take the values as long. Okay, so in the priority queue also I'm taking value as long. So why not take the I as also long? So I can say this is also as long. Okay, I'm taking everything as long. So what I'll be doing is while my ABC, okay, ABC dot size greater than 1, sorry, I'll be having my first value. So what is my first value? If you have elements in the queue, if you remove the queue, that is your first value, right? So what I can write is in my first equals to abc dot poll, okay, and my second is equals to abc dot poll, okay. So I've got my first and second, okay. First value once you have removed, then the second value also when you remove, it is like that. So what I can say is these values has to be long, okay. So long, 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 okay. So then long, we have already taken a long sum value. So we can write long sum is equals to our first plus second, okay. And in this, what we are going to do, we have to do long sum. Yeah, we have to do long sum. And in our cost, we are going to update, right? So cost plus, or you can write cost equals to cost plus sum. Okay. Now we have updated the sum. And lastly, what we have to do is in the priority queue, abc dot add, we have to add the particular sum. Okay. We have to add the particular sum. Once the while loop is done, we can return our cost functions cost, and we can try to compile this. abc abc dot add array of I. What is the problem? Possible loopy incompatible times Lucy conversion from long to int abc dot add array of I. Okay. Add array of hmm, let me just fix this code using a Klook AI tool, because you know, just fix. So what I can write it over here, I can write it over here, long I in array. That is what they did, long I in array and abc dot add I. So they can just, I guess this should work. So we have completed this. Let us submit our solution. So yeah, we have solved 210 days in GFG, which is a long time. And we are looking forward to solving more particular problem statements. And what you can clearly see is this is a priority queue. We are adding the elements to the queue, and this is the cost. And the first and second elements are being extracted. We're storing the sum. And in the cost also, we are going to update the sum. And in the queue also, we are going to update the sum. That's how this problem has to be done. So make sure you guys like, share, and subscribe to the channel. And thank you so much.